Hey, for our final project, we did a regression comparison. My name is Manoj.
I'm Nolan.
And I'm Matthew. So for our project, we mainly set out to determine whether or not scikit-learn or Julia's linear algebra library was more accurate when given the same data set, specifically in reference to regression. So we wanted to run the same well-known regression code on both and then analyze the differences between the two. Our approach was we just ran the same well-known regression on both codes, and we analyzed the difference in the results between the two. So we took a generated noisy data, which was gathered using linspace and the Runge function, and we ran regression on the same data for both scikit-learn as well as Julia's linear algebra library. And we calculated the mean square error as well as the R-squared score from the data that we got from the regression. And then we compared them. And we also compared the runtime. We wanted to do this because regression is widely used in a variety of machine learning applications. And this project could provide valuable insight into the pros and cons of both scikit-learn as well as Julia's linear algebra libraries. And we wanted to look into the relative performances of each, and maybe that would help someone choose which one is better for what they want. So we also wanted to do this on a personal note because all three of us have had some sort of machine learning library to use in some class or another. And using these insights between which one might be better compared to the other one would help us make a more informed decision.
Yeah, like Matthew was saying, there's a lot of good insights we can gain from this. And not only are they beneficial for us, but they're also beneficial for people out in the industry, like data analysts, data scientists, and researchers. All of them could, use this analysis and, help pick better libraries for their numerical computations. So now getting to the graphs that we created here on the screen right now, you can see the Python graphs, more specifically the linear regression model that we created using scikit-learn. To the left here, you can see a graph that has a noise limit of 0.1. Just looking at the graph, it looks like a pretty good regression model. The regression fit line in green looks pretty good compared to like on the data. And another good indicator is the mean squared error that's printed above. So we have a mean squared error of 0.012, meaning that it is pretty accurate. This is a pretty accurate regression model. On the other hand, you can vary your noise limit, and we have an example of this on the right-hand side. If we varied it all the way to 0.9, an extreme in this case, you can see just based on the graph that this regression model isn't a good fit. And the MSE also proves that by giving us one that's pretty high, that's 0.8. And now going to the Julia graphs. So on the screen right now, you can see the graphs that we created in Julia, the linear regression models that we created in Julia. And on the left, you can see the noise limit of 0.1. And we did both of the regression comparisons had the same noise limit, so 0.1 and 0.9. And you can see that the 0.1 noise limit created a graph that's very similar to the one that Python created. But the difference here comes in when you're looking at the mean squared error. So we had a mean squared error of 0.12 for Python, but Julia is giving us a mean squared error of 0.1. So it's small, but it's a big difference. And there, Julia is more accurate just looking at the mean squared errors. And you can also see that at the extreme, when the noise limit is 0.9. Of course, this is not a good regression model, but the mean squared error is a little significantly less by 0.1. So Julia in general is a little more accurate compared to Python.
Great. And in terms of outputs, you can clearly see that the results are very similar. For the baseline data, there's almost no discrepancy. It isn't until we added in the noisy data that you really see those differences. With a noise limit of 0.1, you can see that the mean squared error for Python was 0.012, whereas for Julia it was about 0.011. In terms of runtime, Python had a runtime about 0.76, whereas Julia was about 0.12. These might not seem very significant, but you can tell that based off these parameters, Julia definitely beats Python in terms of efficiency and in terms of accuracy when running this regression model. And in terms of the origin of these discrepancies, where these differences come from, it really comes down to Julia being a high performance, high level math language. It's geared towards specifically linear algebra kind of specific applications, whereas scikit-learn is definitely geared towards more deep learning applications. And while you could gain the same result with each library, with either library, this really shows how important it can be to putting some thought into making sure you're using the right tool for based off of the specific needs for the application you're working on. Even though these discrepancies, these differences seem really small, when they end up affecting your overall end result, they can be very significant. So it's definitely something to keep in mind. If you have any questions, feel free to reach out to us. On Zulip, our names are the same as they're listed below, or send us an email and we'll be willing to chat about the project. Thank you.